So we need an antiderivative to help us evaluate an integral like this, and to make that happen, or for any integral that is. To make that happen, we should use U substitution. Let U be one of the more complicated pieces. I see that we have a trig function being squared, so I'm going to let U be sine of t, and I chose that because I know I'll have du. I need to have a du in order to make this the complete substitution. Du is going to be cosine t. Right? Because if you say u is sine of t, then the derivative of sine of t with respect to t is cosine t. So we can make a substitution now. We can say that this is u being squared du. Now the integral is in terms of u. We've completed our substitution. The last thing to note, though, is that the limits of integration aren't in terms of x anymore. They're in terms of u. So the easiest way to handle that is to wait until you put things back in terms of t, not x, sorry. So I'm evaluating an indefinite integral right now. Power goes up by 1, so that's u to the third over 3. And then we evaluate that from pi. Oh, wait, sorry, not yet. Now we've got the antiderivative. Now we can put it back in terms of t. So u is sine of t. This is sine to the third power of t. And then we evaluate that from pi over 4 to 3 pi over 4. So if you plug in 3 pi over 4, that's 135 degrees like we did in pre-calculus. So let's see, 3 pi over 4, that has a reference angle of pi over 4, which is 45 degrees, and that has square root of 2 over 2 for a sine ratio, because it's the opposite, divided by the hypotenuse for sine. And so this is the method of memorizing two special triangles. This might not be the method your pre-calculus teacher taught you, but you can memorize two triangles, and I've got videos on those. But draw your angle, 45 degree reference angle is where we end up. So the 45 triangle drawn in the unit circle has square root of 2 over 2, square root of 2 over 2, and 1. So the opposite divided by hypotenuse is square root of 2 over 2. That's being raised to the third power, so we got square root of 2 over 2, all to the third power. Then this is still being divided by 3. And then I need to plug in pi over 4. So pi over 4, oh sorry, so yeah, sine was positive. I forgot to check whether sine was positive. Okay, that's right. So if I plug in pi over 4, then I've got square root of 2 over 2 again, the third power over 3. These are the same expressions, the same results, so it's 0 for a final answer.